This video is on the objective complete the steps of a two-mean hypothesis test with population standard deviations unknown. So that means that you'll eventually make use of the student's t-distribution, right? And your test statistic will be a t-score. And this is using the p-value approach, right? So once we have found the test statistic, we'll then determine the p-value using that test statistic, right? And it'll either be an area to the left or an area to the right or double one of those areas depending on what kind of a test it is, right? Left-tailed, right-tailed, or two-tailed. All right. So again, if you want to see more about what they have to say about this, click on More Instruction. Look at their videos, their notes, their examples. Hopefully those help you. All right. So here, a broker who works for an e-trading company is investigating retirement portfolios. The broker would like to test the claim that portfolios consisting mostly of bonds have smaller annual returns than portfolios consisting mostly of stocks. They collect a random sample of predominantly bond portfolios and a random sample of predominantly stock portfolios. The summary statistics in percents are shown in the following table. So you have the sample of portfolios that are bond heavy, and then the other sample with portfolios that are stock heavy, and their sample mean, percent returns, their standard deviations, and their sample sizes. So here we're asked to assume the percents are normally distributed and that the population variances are not equal. Remember, if you're assuming that the population variances are not equal, that means you're in the non-pooled scenario. Now, if they said you're assuming the population variances are equal, that's the pooled scenario, right, where you have to find that pooled estimate for the standard deviation, that SP, and then go from there. And that's been discussed before in previous videos on an assignment before this. So hopefully you recognize the difference between the pooled scenario and non-pooled. Here, this is the non-pooled scenario. All right. At the 1% level of significance, right, alpha is 0.01, is there sufficient evidence that the mean annual return is less for portfolios consisting of bonds than stocks? So they're telling us to let mu1 represent the mean annual return for portfolios that are consistent mostly of bonds, and mu2 represent the mean annual return for portfolios consisting mostly of stocks. Alright, so first we're asked to just identify the null and alternative hypotheses. Alright, so I'll go to some paper. Now remember, the claim that they said in the first sentence, the claim being tested is that portfolios consisting mostly of bonds have smaller annual returns than portfolios consisting mostly of stocks. So mu1 is less than mu2, right? Remember, mu1 was for the portfolios with bonds, mu2 was the average for the portfolios with stocks, and this is saying the bonds are have a smaller annual return than stocks on average. Now, an alternate way to say this would be that mu1 minus mu2 is less than 0. You could also say this. And then once the claim, or what's being investigated, what's a belief, what's a claim, once the claim is established, you can then state your hypotheses, the null hypothesis and alternative hypothesis. This does not involve equals, so it is represented by the alternative hypothesis. Mu1 is less than mu2, or mu1 minus mu2 is less than 0. And then the null hypothesis is the opposing statement, that mu1 is greater than or equal to mu2. But when we actually perform the test and go through future steps, what we're going to take out of this is we're going to be assuming that mu1 equals mu2, or that mu1 minus mu2 is equal to 0. Right. Okay, and that's all we're asked to establish right now. Right, this null and alternative hypothesis. And another thing I can see from this too is the alternative hypothesis involves a less than. So this tells me this is going to be a left-tailed test. So when I go to calculate the p-value of my test statistic, it's simply going to be the area to the left under the curve. Alright, so back here. Now, I wonder if they'll take the greater than or equal to. Because usually it's just equal to. Alright, well let me see for your benefit. Let me just do the cheat here and see what comes up. Okay, so they're just putting what they assume. Alright, so stick to what you've been used to doing, when you're filling out these steps. In the null hypothesis, we're assuming that mu1 equals mu2. And as I mentioned, the alternative hypothesis was that mu1 was less than mu2. Right? Right. Then the next step after this is going to continue on for sure. Alright, so it's the same question, same sample information given here. Now we're asked to calculate the test statistic, and the t-score for our sample mean, the difference in our sample means, x1 bar minus x2 bar, and round your answer, to the nearest hundredth. Remember alpha here. Alright, so usually after the hypotheses are mentioned, we'll write out the significance level, and they said the significance level here was 1%. Right, alpha was 0.01. And then we take our samples, and I'll write out the sample information here. Right. So we take our samples from these two populations. Now we have the bond portfolios and the stock portfolios. And the sample size for the bond, the bond portfolios, N1 was 18. The sample mean, right, the mean percent return was 4.7%. Right, so x1 bar was 4.7. And the standard deviation for the sample of bond portfolios, S1, is 0.6. And then for the stock portfolios, N2 is the sample size. For there's 17 of those. X2 bar is 5.6, right? So the average percent return for the stock portfolios was these 17 stock portfolios was 5.6%. And S2 standard deviation for sample 2, 1.4. Right. Now, remember they said we're assuming that the populations are normal, but we're also assuming that the standard deviations of the populations are not equal. So that means we're in that non-pooled situation, the non-pooled scenario, as opposed to the pool scenario, pooled. Alright, so we're non-pooled, meaning that the distribution of x1 bar minus x2 bar, the difference in our sample means. If we were to look at all possible differences of sample means for samples of these sizes, the distribution of the difference in sample means would be a student's t distribution, right? With, now, in the non-pooled scenario, remember the number of degrees of freedom was the smaller sample size minus 1, just to be more conservative, for a very conservative estimate. So the smaller sample size here is 17, minus 1 is 16. So we're looking at a student's t distribution with 16 degrees of freedom. And I'll draw this. Here's an axis with t-scores. Got the symmetrical bell shape. The t-score under the peak is 0. And now what I'm going to be looking for is, where is my test statistic? Now, if you recall, again, the way you calculated the test statistic was different, and go back to previous videos in a previous assignment where you were finding the test statistic for a non-pooled scenario and a pooled scenario. I'll refresh your memory for the non-pooled here. The test statistic is the following t-score. We take the difference in our sample means, right, our x1 bar minus our x2 bar. I subtract the difference in population means that are assumed from the null hypothesis, which is 0. Right? From the null hypothesis, we'd assume that mu1 minus mu2 is equal to 0. So minus 0, so no need to write that. And then divided by the standard deviation of the distribution x1 bar minus x2 bar. And that standard deviation was this big square root thing here. Square root of, s1 squared over n1 plus s2 squared over n2. Alright, so plugging in all the numbers we have, and again I got all my sample information up here, this t-score, this test statistic, the numerator is 4.7 minus 5.6 divided by, then the denominator square root of s1 squared, right? So 0.6 squared divided by n1 plus s2 squared, 1.4 squared, divided by n2, divided by 17. And we're asked to round this to the nearest hundredth, right, to 2 decimal places. So I'll pull up the calculator and we'll punch this in. Now the numerator, 4.7 minus 5.6 is negative 0.9. So I'm not going to type all that, I'll just put negative 0.9 for the numerator. Then divided by the square root, and then make sure all of this down here is inside your square root symbol. So we have 0.6 squared, s1 squared divided by n1, divided by 18, plus, and then the s2 squared, 1.4 squared divided by n2, 17. And that's all under the square root, and we get to 2 decimal places. This would round to negative 2.45, right? Because it's 446. And I'll put that on my picture, right? The picture of my t distribution. So negative 2.45 is where that's over here somewhere, to the left of 0. All right, there's our test statistic. And this is a left-tailed test, right? We said that earlier, left-tailed test. So the p-value is simply going to be the area to the left of this test statistic, right? Which I can find on my calculator using the tcdf function. So I go to my calculator here, and I go second, distributions, down to TCDF, right? We're finding the area under a T curve. This area to the left here, there's no lower values, so I got some big negative number there already. The upper value is my test statistic, negative 2.45. And the number of degrees of freedom I mentioned was, again, the lower, because it's non-pooled, was the smaller sample size minus 1. So just 16, that was 16 degrees of freedom. And we're coming back here with about 0.013. So the p-value is, again, this area is approximately 0.013. And then we had to compare that to alpha. Now, alpha was 0.01. This is bigger than that. This is bigger than alpha. So I'm going to fail to reject the null, and we'll get to all that in a minute. Let's go back, enter the test statistic, right? So back here, we're asked to enter the test statistic rounded to the nearest hundredth. I said it was negative 2.45. And again, I go through all the same calculations I just showed you. Right, yep, do. So still the same question. And now you can use this table. Now I already, oh, okay, they're saying use the table to tell you what areas it's between. So now we said it was a T distribution with 16 degrees of freedom, right? So I'm looking at this table, this row. Now our test statistic was negative 2.45, but these are all positive T values here. So just look at, instead of the area to the left of negative 2.45, let's see what the area to the right of positive 2.45 would be. Now positive 2.45 is between 2.120 and 2.583, between these two. So that means the area to the right of positive 2.45 is between 2.5% and 1%, or 1% and 2.5%. And if the area to the right of positive 2.45 is between 1 and 2.5%, then our p-value, the area to the left of negative 2.45, would be the same, between 1%, right, 0.01, and 2.5%, 0.025, which I already told you it was, right? We said the p-value was 0.013. It's definitely between these two. And degrees of freedom I already mentioned was, the smaller sample size, minus 1, 16 degrees of freedom. Okay. All right, and then finally we make our decisions and conclusions. Now remember, the p-value was 0.013. So back here, right? So the p-value was 0.013. Alpha was 0.01. So what we're seeing here is that the p-value is greater than alpha, right? Is greater than the significance level. And if that is the case, we do not reject the null hypothesis. Right? We fail to reject the null hypothesis. So let's go back and look at our hypotheses. Now the null hypothesis, what we assumed in the null hypothesis was this, that their rates of return, their average return rates were the same for bonds and stocks portfolios. And we're not rejecting that. We're keeping that. Meaning that we're not accepting the other one. So I'm going to put a big X to the alternative hypothesis. And this was the claim here, right? The claim was the alternative, and we're saying we're not supporting it. We're keeping the null. We're keeping this and not supporting the claim. So there's not enough evidence to say that, bond portfolios have a smaller return rate than stock portfolios. There's not enough evidence to say that in these samples. All right, so let's see which of these options says that to us. So it's one of these two, right, where we fail to reject the null. let's see what the first one says. It says, there is not enough evidence, not sufficient evidence to conclude that the mean annual return is less for portfolios consisting of bonds and stocks. That's what I just said, right? There's not enough evidence to state that claim because we didn't reject the null hypothesis. So I'll answer that. And wonderful. And it looks like, again, I mean, all these objectives where you have to complete all the steps of a full hypothesis test, you may have noticed in the past videos that, if you take your time and get through it all, the one question, and do all the steps properly, that'll be the only one you're going to have to do, and the objective will be over. So now if you get things wrong, it's going to throw more problems at you, more questions. It'll be a little longer, but take your time. Make sure you know, is it what are my hypotheses? What's the alpha? Is it a right-tailed, left-tailed, or two-tailed test? What are my sample statistics? Is it a pooled or non-pooled scenario? Am I assuming the population standard deviations are equal, or am I not assuming they're equal? Pooled versus non-pooled, and that'll determine how you calculate the test statistic, and also how you determine the degrees of freedom for the t-distribution. Then once you have the test statistic, find the p-value, compare that p-value to alpha, and then you decide if you're going to reject or not reject the null, and then you make your conclusions. Right. So it's the same steps though every time. Just a little more here because you have a lot more to pay attention to. Pooled or non-pooled. But it's the same steps really. So hopefully watching my video and looking at more instruction, reading the answer explanations, hopefully all this stuff helps you out when you're working on this on your own. And thanks for watching.